Hi students, today we are going to learn about some of the measures of the exterior angles of a polygon. So if there is any polygon, we are going to measure the exterior angles. So here I consider one polygon and it have exterior angle 1, 2, 3, 4, 5. 5 angles are there in the exterior. So what will get by adding all these 5 angles. So consider that you are in the starting at A and walking towards this line, and you will reach a B, and you are taking any angle 1, and again you are walking till you are reaching the C, and the C you need to change the angle 2, and you will be reaching a D, and from D you are just turning to the angle 3, and you just come back again to E, and again with the angle 4 you are turning, and you can see again you will meet at the point A itself, right? It is like in a one complete turn. So here A you turn lightly one, and B, C also you turned, and D also you turned, E also you turned, and again you reach at the same point. It's like in a complete turn. So what is a complete turn? It's a 360 degree, right? Complete angle is called as a 360 degree, the same. So if you add all this angle, it will be like a 360 degree. Measure of angle 1 plus measure of angle 2 plus measure of angle 3 plus measure of angle 4 plus measure of angle 5 is equal to 360 degree. So therefore the sum of measure of the exterior angles of any polygon is 360 degree. So for any polygon you can try, it will be a 360 degree. So here we go for the problems. Find the x. It is given a triangle, and you can see that it is given 3 angles also in the exterior. So directly we can use the exterior angle of the polygon. So what the exterior angle of the polygon? The sum of exterior angle is 360 degree, right? Sum of exterior angle is 360 degree. Sum means addition. We have to add this 3 exterior angle, that's a 125 degree plus 125 degree plus x is equal to, it's given a 360 degree. What is 125 plus 125? 250. So 250 degree plus x is equal to 360 degree. So x is equal to 360 degree minus 250 degree. So x is equal to 110 degree. So the value of x is equal to 110 degree. Here we go for the next problem. Find the measure of each exterior angle of regular polygon of 9 sides. There is a regular polygon with 9 sides. So regular means it having a equal sides as well as an equal angle. Totally how many angles are there then? 9 sides. 9 sides, and there will be angle 9 angle, right? And the 9 exterior angles will be there, and it said regular, so 9 exterior angle is also a equal, and they are asking what is the measure of each. So each measure of the exterior, we know the sum of exterior angles are 180, right? Sorry, 360. Sum of exterior angles are 360 degree, right? Sum of exterior angles are 360 degree. So totally how many exterior angles are there? 9. And the 9 exterior angles are also the same, right? So let me consider it as a x. So totally how many angles will be there? X angles, right? So how many angles are there? 9 angles. So x plus 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 x is equal to 360 degree, right? Totally 9 angles are there. If you add the 9 angles also, it should be a 360 degree. So it is a 9x is equal to 360 degree, and x is equal to 360 degree divided by 9, while multiplication bring it to division, and x is equal to 9 table, it will be 4 times, and it's a 40 degree. So the each exterior angle is therefore each exterior angle is 40 degree, right? Next, how many sides does a regular polygon have if the measure of an exterior angle is 24 degree? So here it's the measure of each exterior angle is given as a 24 degree. It's a regular polygon, and it all are the same. They're asking to find the number of sides. So let me consider, let n be the number of sides or vertices. Both are the same, right? How many sides there are there? So how many, that much vertices will be there, or vertices. Vertices is not just a point where the angle will be made. So totally there is a 24 degree. So each angle is a 24 degree. If we consider n number of sides, then there will be n number of angles. So n number of angles, if we add it, then we will be getting a 360 degree. That is what said, sum of exterior angles are 360 degree. So totally is n number of vertices, and n is also a 24 degree. So let me consider n into 24 degree is equal to 360 degree. So 24 will be divided. So n is equal to 360 divided by 24. So if you divide the 24 table, it will be a 15, right? Therefore there will be a 15 side. Therefore there are 15 sides. Here we go for the next problem. How many sides does a regular polygon have if each of its interior angle is 165 degree? So it is given an interior angle. They ask about the sides. It is also just like a previous problem, but here is given the interior angle. Just you find an exterior angle with the interior angle. If it is the pentagon, so example, just I am considering it as a pentagon, and this angle is a 165 degree. Then what will be the exterior angle? Exterior means you have to extend here. This angle will be the exterior angle, right? What will be the exterior angle? It's a straight line, right? Linear pair. So 180 minus 65, right? So given interior angles is 165 degrees. Since we are doing, it's a regular polygon, so all the angles are the same, right? Therefore the exterior is, so exterior angle is 180 degree minus 165 degree, which is equal to 15 degree. So there is a 15 degree. We need a number of sides, the same like a previous problem, right? Sum of exterior angles are 360 degree. So each is a 15 degree. We don't know how many sides, so same we'll consider as a n. So n into 15 degree. So n angles will be there. So n into 15 degree, there should be a 360 degree. That's what the sum of exterior angles of any polygon give, right? This formula, always remember, this condition is for any polygon. Here also just given a regular polygon. It can be any polygon, but we can use this condition. So given, considering the n is the number of sides or number of angles, both are same. Sides and angles, number of sides and number of angles will both are same for any polygons. So consider n into 15 degree should be a 360 degree according to the condition. So n is equal to 360 degree divided by 15 degree. So n is equal to 24 degree. So there is an 24 angles are there. If there is a 24 angles, then there should be a 24 sides. Therefore there are 24 sides. Clear? So here we go for the kinds of quadrilateral. So there are 5 kinds of quadrilateral we are going to see here. So first kind we are going to see about is a parallelogram. So parallelogram is in this shape, and what are the properties that satisfies for the parallelogram? Just if it is a quadrilateral, that's just, it says a 4-sided figure, but while it comes to the parallelogram, it satisfies some properties. The first property is opposite sides are parallel. These two sides are parallel, which AB is parallel to CD and AD is parallel to BC. These opposite sides are parallel. And next property is opposite sides are equal. So the length of the AB is equal to DC, and the length of the AD is equal to BC. Length will also equal. Opposite sides. Clear? Then opposite angles are equal. So angle A is equal to angle C, angle B is equal to angle D. And the final condition, diagonal bisects one another. So diagonals we have drawn in the dotted lines, it bisects one another. Bisects means it cut equally. So just return that center point as an O. So it cut equally means AO will be OC. It cuts equally. So AO is equal to OC and OD is equal to OB. These are the properties of the parallelogram. Remember, opposite sides are parallel, opposite sides are equal, opposite angles are also equal, diagonal bisects one another. So here we go for the next problem, rhombus. The properties is all properties of parallelogram. So what are the properties satisfied there? That the opposite sides are equal, opposite angles are equal, and opposite sides are parallel, and diagonal bisects each other. All properties satisfies rhombus, and also along with the two more. All sides are equal. There only opposite sides are equal, sir, but in the rhombus all sides will be the equal. And diagonals are perpendicular to each other. It will bisect, also it is perpendicular. Perpendicular means 90 degree. It will draw, it will bisect, and also this angle will be a 90 degree angle made. So in the center there is a 4 angle made. 4 angle is also a 90 degree. So next is a rectangle. So rectangle properties are all properties of parallelogram. Same, opposite sides are equal, opposite angles are equal, and opposite sides are parallel, and diagonal bisects each other, along with each of angles are right angle. You can say all the angles are right angle. So it satisfies the parallelogram properties also. It says opposite sides are equal. Yes, now it's still it's equal, right? All sides are 90 degrees, so opposites also will be equal. And diagonals are equal. The diagonal full length, if you draw a diagonal KM and LN, KM is equal to LN. It will bisect. If you take O, KO is equal to OM and LO is equal to ON, which is the properties of parallelogram, and also the KM will be is equal to LN. Clear? We'll go for the next property, next shape. It's a square. The property is all the properties of parallelogram, rhombus, and the rectangle. It says all sides are equal or opposite sides are equal. If all sides are equal, surely its opposite sides are equal, right? And all angles are equal, and all angles also 90 degree, which is set in the rectangle. It says rectangle also satisfies. So opposite angles are also equal. All angles are also equal. And what about the diagonal? Diagonal will bisect each other, and length of the diagonal is also equal. We can say PO is equal to R, QO is equal to OS, as well as we can say with the rectangle PR is equal to QS. Diagonal is also equal, right? So all the properties of a parallelogram, rhombus, and rectangle, all properties will be satisfying. Then it is a square. And here we come for the next shape. It is a kite. A kite is little different from all other shapes that we have seen so far, right? The properties are two pairs of equal consecutive sides. Two pairs of equal consecutive sides. Consecutive means next. So next to this AD, the side is AB will be the equal, and here the BC side will be equal to DC. So two consecutive sides are equal. But previously we saw opposites are equal, all are equal. They didn't saw that consecutives only equal, right? So it is different here. And diagonals are perpendicular to one another. If you draw a diagonals, and it says it's a perpendicular to one another, that we saw already, right? It's in the rhombus rectangles I have. And one of the diagonals bisects another. Only one diagonal is bisecting another, not a both diagonal. From the figure you can say this point is O, then you can say DO is bisect OB. We cannot say AO is equal to OC, right? Because it is smaller, little it is greater in length. From the rough figure itself we can understand, right? So only one one diagonal is bisecting, that is DO is equal to OB. The smaller diagonals we can say they are in equal length. So next is about an angle. Angle B is equal to angle D, but angle A is not is equal to angle C. So angle B and angle D. So the which diagonal sides are equal? I said that angle will be the equal, but angle A and angle C is not equal. So it is also given, right? Since these two sides are in different equal, these two sides are different, but while comparing these both sides it's a different, right? So the angle also may be vary. That's why angle A and angle C are not equal, and angle B and angle D and B are equal. Clear? Thank you.